Welcome sa modern or math in the modern world. At nasa finals part 1 na tayo ng ating course. So for our first part ng finals, we are going to discuss logic and reasoning. So mathematics started as a practical technique to immediate problems in life. Mathematics later is established as a deductive science in which the standard of rigorous demonstration is deductive proof. Aristotle provided a codification of logic which remains definitive for 2,000 years. The axiomatic method is established and is systematically applied to the mathematics of the classical period by Euclid, whose Elements becomes one of the most influential books in history. The next major advances in logic after Aristotle appeared in the 19th century, in which Boole introduces the propositional Boolean logic and Frege devises the predicate calculus. This provides the technical basis for the logicization of mathematics and the transition from informal to formal proof. So define natin kung ano yung logic. Logic is the science of reasoning, proof, thinking, or inference. Logic allows us to analyze a piece of deductive reasoning and determine whether it is correct or not, to determine if the argument is valid or invalid. It is a tool used in mathematical proofs. The rules of logic specify the meaning of mathematical statements. For instance, these rules help us understand and reason with statements. Logic is the basis of all mathematical reasoning and of all automated reasoning. Logic is a tool for working with complicated compound statements. It includes the following: a language for expressing them, a concise notation for writing them, a methodology for objectively reasoning about their truth or falsity. It is the foundation for expressing formal proofs in all branches of mathematics. A mathematical proof is an argument that begins with a set of postulates or assumptions and proceeds to a conclusion by agreed methods of argument. A deductive argument is one that, if valid, has a conclusion that is entailed by its premises, meaning the truth of the conclusion is a logical consequence of the premises. If the premises are true, then the conclusion must be true. A proposition is a declarative sentence, that is a sentence that declares a fact that is either true or false, but not both. As a declarative sentence, it expresses a complete thought with a definite meaning. For example, St. Louis University is in the city. Quezon City is the capital of the Philippines. Benguet is a part of the Cordillera Administrative Region. 1 plus 1 is equal to 2. 2 plus 2 is equal to 3. So manonotice nyo whether it is true or false, proposition ang tawag natin dyan. For example, 2 plus 2 is not equal to 3. But still, ang statement na to ay considered as proposition because they all have truth values. Pag sinabi nating truth value is either true or false. But not all sentences are considered propositions. Example, what day is today? Second, read the instructions carefully. Again, number 3, 5x plus 1 is equal to 2. The fourth one, x plus 2y is equal to 3z. Sentences 1 and 2 are not propositions since they are not declarative sentences. This is interrogative sentence. Siya ay nagtatanong. So that is not a declarative, which is the requirement for a sentence to be a proposition. So dapat declarative siya. Since ito ay interrogative, so hindi natin siya pwedeng sabihin siya ay proposition. Also number 2, read the instructions carefully. Hindi rin siya declarative since siya ay nag-uutos. So ito ay authoritative na statement. So sentences 3 and 4 are not propositions because they are neither true nor false. Sentences 3 and 4 can be turned into a proposition if we assign values to the variables. Okay, so bakit yung 3 and 4 hindi proposition? Dahil si X hindi natin alam kung ano talaga ang kanyang value. So ang statement na to, hindi natin alam kung totoo or hindi, no? Kung true or false. The same way with number 4. Okay? So if we assign values daw to the variables, for example, si x ay 2, si x ay 3, then we can say that these two statements, mathematical statements, are a proposition, no? Mathematically, the propositions are converted symbolically. We use the letters to denote propositional variables or statement variables, that is, variables that represent propositions, just as letters are used to denote numerical variables. So the conventional letters used for propositional variables are P, Q, R, S. The truth value of a proposition is true, denoted by T, if it is a true proposition. And the truth value of a proposition is false, denoted by F, if it is a false proposition. Many mathematical statements are constructed by combining one or more propositions. New propositions, called compound propositions, are formed from existing propositions using logical operators or logical connectives. Logical connective is a word or symbol that joins two sentences or propositions to produce a new one. The 5 basic logical connectives are conjunction, disjunction, implication, biconditional, and negation. We have our table here for the 5 connectives. Number 1, conjunction. Connective keyword natin ay and for conjunction, and ang symbol natin is an inverted V. Okay? For disjunction, we have the connective keyword or, and we have the symbol letter V. Sa implication or conditional, which is if, then, ang keyword, ang symbol natin ay arrow. And sa biconditional, which is ang keyword natin, if and only if, and ang symbol natin dyan ay double arrow. And sa negation, ang keyword natin ay not, at ang kanyang symbol ay hyphen, no? So ang basa dyan ay not, if and only if, then, or, and then, and. Conditional statements play an essential role in mathematical reasoning. They are often seen in the different theorems of mathematics. They are different ways of expressing. For example, if P, then Q. So marami daw ways, no, kung paano basahin to or express, no? The common ones encountered in mathematics are P implies Q, or if P, then Q. Ito yung gagamitin natin. If P, Q, if P is sufficient for Q, Q if P, Q when P, a necessary condition for P is Q, Q unless not P, P only if P, a sufficient condition for Q is P, and Q whenever P, Q is necessary for P, and Q follows from P. So makikita nyo, mas madaling basahin si if P then Q, no? As compared to other expressions, no? Negation of mathematical statement P is denoted by not P. So, itong hyphen na to ay pwede rin nating i-replace with this symbol, no? So, ang basa dyan ay not P, a symbol for not. Yan. Okay, so ito i-replace natin na ang ganitong symbol, no? So, if P is true, then not P is not true. Okay? So, examples, P, the trainees are sleepy. Kapag ninegate natin siya, so may symbol na negation symbol, so ang basa na natin, the trainees are not sleepy. So kapag negation, nilalagyan natin ng word na not, yung sentence, no? Sa Q, I have a new phone. Kung not Q, I do not have a new phone. Okay? Truth values, summary of truth values of compound statements using logical connectives. So makikita nyo, ito yung ating sentence 1. Tawag natin dyan ay premise. So premise 1, premise 2. So kapag pinagsama natin sila, we will have the evaluation or evaluated truth values. No? Ito yung truth values nila. Yan, true, 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 false, false, true, false, false. Pag in-evaluate natin sila using different connectives or pinagsama natin sila, kaya ang tawag sa kanila connectives or operators, no? Pag pinagsama natin sila or pinag-compare or binagyan ng relationship, no? We can have or we can evaluate the evaluated truth values. Okay? For example, kung dito ang gamit natin is and, dito ang gamit natin or, ito naman is if then, ito naman ay if and only if. Okay? So may kanya-kanyang rules yan. Okay? So if si P daw ay true, si Q ay true, ang evaluation natin sa P and Q is true. Yan. Kasi ang rules sa end connectives or end connector, dapat pareho silang true para yung evaluation natin ay maging true. Okay? So itong the rest na condition niya, which is yung may itong mga to, ay ang result natin dyan ay false na. Because hindi sila parehong true in these three instances. Sa or naman, ang condition natin para maging true is either of them must be true. So that ang ating evaluated result or truth value is also true. So manotice nyo, walang true dito sa last instance. So ang ating evaluated truth value is false. Next, if P then Q, ang magfo-false lang ang evaluated truth value natin dito if si P daw ay true and Q is false. So ang evaluation natin ay false. So manonotice nyo, true na lahat ang kanyang instances. No? Bakit? Kasi although true dito sa first instance niya, true dito si P, pero hindi false dito si Q. So ang sagot pa rin natin, ang evaluated truth value natin ay true. Okay? Next, sa P and only if Q, reverse naman tayo. Okay? Magiging true siya kapag pareho silang true or parehong false. The rest, magiging na siyang false. Okay? The conditional statement can be transformed to new conditional statements. In particular, there are three related conditional statements that occur so often that they are given special names. These are the converse, the contrapositive, and the inverse. The contrapositive always has the same truth value as the conditional, assigning P as the antecedent or hypothesis and Q as the consequent or conclusion. The conditional and the implications or transformation of it is as follows. So kung ito daw si P ang ating hypothesis and si Q ang ating conclusion, then we have the following transformation or implications. No? Conditional, if and only if Q. If P then Q. Converse naman, babalik rin natin yun. No? So conditional, if P then Q, then babalik rin natin for the converse, if Q then P. Okay? Pag inverse naman, babalik rin natin yung conditional but hindi yung position, no? Yung kanyang negation. No? So lalagyan natin siya ng negation, ibig sabihin not P. If not P, then not Q. Yung contrapositive, babalik rin natin yung position niya. The same way with converse. So mapapansin nyo, yung contrapositive, binaliktad natin si inverse. Si converse naman, ay binaliktad natin si conditional. Okay? Si inverse naman is, ninegate natin, ni-reverse natin si conditional, not the position, but its negation or truth value. Okay? When two compound propositions always have the same truth value, we call them equivalent. So that a conditional statement and its contrapositive are equivalent. Sabihin itong dalawa, equivalent. The converse and the inverse of the conditional statement are equivalent statements, but neither is equivalent to the original conditional statement. An important thing to remember is that one of the most common logical errors is to assume that the converse or the inverse of a conditional statement is equivalent to this conditional statement. Okay? So, in order for us to deduct, no, an argument, a valid argument, no, Ang ating babantayan lang is dapat yung ating converse and inverse, wag nating i-assume na pareho siya sa conditional. Okay? A deductive argument is one that if valid has a conclusion that is entailed by its premises, meaning the truth of the conclusion is a logical consequence of the premises. If the premises are true, then the conclusion must be true. Logical argument has three stages. Number one, premises. Ano yung premises? The claims that are given in support of an argument. The building blocks of a logical argument. A premise is a propositional statement which is either true or false. Okay, yun yung ating basic two statements, no, leading to the conclusion, no. Inference, the logical move from one or more premises to arrive at its conclusion. All inferences must be abide by a rule of inference or an argument to be valid. Ito na yung ating parang analysis of those statements or premises. And then yung ating result, conclusion, evaluation, the premise that is the consequence or product of the above premises plus the inference. A conclusion can then itself become a premise, building block of a continued or new argument. Symbolic logic symbolizes arguments for simple, efficient assessment of validity. As arguments get longer and more complex, symbols are especially important. So how do we write an argument in symbolic form? Write arguments in symbolic form and valid arguments. Given proposition, for example, I have a college degree. So inassign natin yung unang statement natin as P, I am lazy. The second statement as Q, using the propositions and creating an argument. If I have a college degree, then I am not lazy. I don't have a college degree, therefore I am lazy. So, yung mga statement natin, lalagyan natin ng assignment, no? Yung P, Q, and then also yung diniscuss natin sa taas, the symbol for the connectives and connectors or operator, no? Symbolic form, if I have a college degree, then I am not lazy. So, ang representation natin ito, if P, then not Q. I don't have a college degree is represented by not P. So, remember yung ating not negation, ilalagyan natin ng negative, no? Yung statement is either don't or not, no? Depende sa sentence. In this case, I don't have a college degree. Notice yung unang statement natin ay hindi negated, no? If I have a college degree. So, kapag not P na, ninegate na natin si P, meron na dapat siyang don't, no? So, I don't have a college degree. Therefore, I am lazy. So, ang ating hypothesis, if P, then not Q, and remember yung reverse or inverted V ay and not P. So, itong tatlo represented by this hypothesis. So, if I have a college degree, then I am not lazy. I don't have a college degree, therefore, I am lazy. Okay? So, ang conclusion natin is Q. Yan. I am lazy. Argument in symbolic form. Gagamitin natin to. Yan. Ang ating conclusion, may arrow, Q. So, to test to see if the argument is valid, we take the argument in symbolic form and construct a truth table. If the last column in the truth table results in all truths, then the argument is valid. So, we have the following premises and negated premises. And then we have the following evaluated result using our symbolic form. Okay? The first example ay mayroong isang false, tatlong true, dalawang false sa second, may dalawang true. Ito naman may tatlong true at may isang false. Therefore, this argument is invalid because the last column has a false item. So, meron siyang false kasi dito. Therefore, hindi valid yung ating statement. Okay? Symbolize the argument, construct a truth table, and determine if the argument is valid. For example, it will be sunny or cloudy today. It isn't sunny, therefore, it will be cloudy. S for the first statement, C for the second statement. So it will be sunny or cloudy today. So S, remember, yung ating V ay or. S or C, dahil may or tayo. It isn't sunny, so may not. So sunny is the first statement, so negate natin si sunny. Not S, therefore it will be cloudy. So C, ang ating conclusion, no? So una nating premise, no, it will be sunny or cloudy today. So since it isn't sunny, therefore, ang ating conclusion, it will be cloudy. So tingnan natin kung ito ay magkakaroon ng kung ang ating argument ay true, no? So ito yung ating first premise, second premise, itong ating negation, yung ating inference. Ito yung ating combination ng symbolic form. Okay? So sa first is true, 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 false. Second is false, false, true, false. At pag in-evaluate natin itong dalawa, we will have true, 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 true. So therefore, our argument is valid since lahat ng ating truth value sa last column ay true. Okay? So that is how we determine if our argument is invalid or not valid. So this is for our finals in mathematics in the modern world. And I will see you on the next video for our finals part 2.